Question 10. The diagram shows part of the curve with this equation here and parts of the lines x is equal to 1, y is equal to 1. The curve passes through the points a 1, 4 and then b 3 over 2, 1. Part A, find the exact volume generated when the shaded region is rotated through 360 degrees about the x-axis. Okay, since this is a region between the two curves, then remember this one comes from the two regions. Like this one, when it is rotated about x-axis, we shall form something like that. Okay, so when we try to strip this one, we shall get out a cylinder. Okay, we shall get out something that resembles a cylinder. Now this cylinder here has gotten a radius, but this radius will be equivalent to the y-coordinate from here up to here. That is the y-coordinate. You see that? So meaning r will be equal to y. Then we also need to get the height. This is the one here, but that will be between the two x values. Okay, this will be the height here. So that is a small change in x. And we know that volume of a cylinder is equal to pi r squared what? H. So this one is going to be pi, then y squared delta x. But now, since we are moving from here then to here, we are going to have a big change in the x. So that delta x, then I turn it into dx. Okay. Now, this one is in between two. There is this curve here, and there is also this line here, y is equal to 1. So we want the volume below this one, but there is also volume below this one. So this one which is above, then minus the one that is below. Okay, so that is that we need to get, usually when it is in between two regions, we say that volume of solid of revolution generated by rotating the region about x-axis 360 degrees, we have A to B. So remember, it is pi r squared, the volume. So we are putting this one all together as one thing. Okay, we are having these many cylinders, but now putting them together as one thing, that is integration. Integration is to bring all of the things together as one. Okay, so we shall have the one which is above, that is y squared. Okay, and then also the other one which is down. So we get the one which is above, then minus the one which is down. Okay, then dx. So for this case, we shall have vx, which is equal to pi. I can put this pi outside here because it is a constant. Okay, then we are integrating from 1, the x coordinates we are having here. We are seeing this one here, and then the x coordinate of b, which is 3 over 2. So 1 and then 3 over 2. Then the one which is above is this curve here. Okay, so I will have 4 then into 2x minus 1 power negative 2. Then remember, this one has to be squared. Okay, we have to square it just like I wrote here. Then minus y is equal to 1 here. You see this one here? It must also be squared. So we have that then with respect to x. Now we shall have pi here, integrate from 1 to 3 over 2. And then when I square the 4, that one will be a 16. Then we have 2x here minus 1. Of course, this one will multiply. Then we have a negative 4 here, then minus 1. Okay. Now we begin to integrate. Remember, when you begin to integrate, take away the integral sign. So we have pi, then replace it with the square brackets. So increase the power by 1. We shall have 16 into 2x, then minus 1. This will be power negative 3. Then divide by that new power, but then times the derivative of this one here, which is a 2, because the derivative of this one comes from the chain rule. So in the chain rule, when it now comes to integration, we divide by that derivative. So when we divide it, then it finds this one down, and then it multiplies with it. So that's why we say just multiply by the derivative of what is inside here. Okay, then when you integrate this with respect to x, of course, you will get an x here, and then 3 over 2, then 1. So we have pi here. Now let's put in, of course, this one will go in here 8 times, right? So we shall have negative 8 over 3. Usually we don't write the negatives in the denominators. And then we have 2 times 3 over 2, then minus 1, power negative 3, then minus 3 over 2. Then subtract, now put 1. You'll get, again, negative 8 over 3 into, of course, 2 times 1, that is a 2 minus 1, that is a 1, then negative 3 as the power here, then minus 1. Okay. Now we simplify. What do we get here, and then what do we get here? Negative 8 out of 3. Then inside here we are having, here we shall get a 3. 3 minus 1, that will be 2. Then we have 2 power negative 3, that will be 1 over 8. Okay, then minus 3 out of 2. So this one gives us negative 11 over 6. So we have pi into negative 11 out of 6, then minus, what do we get here? Negative 8 out of 3. And then inside here we have just a 1. Okay, then minus 1. That one will give us negative 11 over 3. So negative 11 over 3. So altogether, what do we get? Of course, this one here is going to turn out to be a positive. So negative 11 out of 6, then plus 11 out of 3. That is 11 out of 6. So we have 11 out of 6 of pi. That will be our volume generated. Part B, a triangle is formed from the tangent to the curve at B, the normal to the curve at B, and the x-axis. Find the area of this triangle. I'm going to do a small sketch here, but let us first go back and we check here. They said that a triangle is formed from the tangent to the curve at B. Tangent to the curve at B. Okay, so if this is point B, then, so this is the one here at B. That is the tangent. Then from there, there is also the normal at B. That is the one that is perpendicular, right? Perpendicular to the tangent. So suppose we draw something like that. Okay, this one is perpendicular to the tangent. This is the normal. Then what else? They said, and the x-axis. That means where this normal meets the x-axis around here. So this is the triangle. Since this and this is 90, very good. So this one is going to be a right-angled triangle. So we need to find the equation of this normal, okay? And then we know where it cuts with the x-axis here. We shall solve these two simultaneously. No, we don't need to solve them simultaneously because where they are meeting is point B, which is known. You see that? Then we also need where this one here cuts the x-axis. Okay, so we need the equation of the tangent at B, then where it cuts the x-axis. You see that? And also the equation of the normal where it cuts the y-axis. X-axis. Then we can find the length of this one using the two coordinates here. And we also find the length of this one. Then we can say a half times base times the height. As simple as that. Okay. So going back here, I will draw some simple sketch here like that. Then I'll say maybe that is our, we have seen that we are going to have a line like this. That is the tangent. The normal. Then we shall have the tangent here. Okay, like that. So this is our curve. And we are having here point B, which is 3 over 2, and then 1. So this is the normal at B, and then this is the tangent at B. So this is y-axis, this is x-axis, this is 0. So we shall need this coordinate we shall need this coordinate. All right. So we have y, which is equal to 4 into 2x minus 1 to the power of negative 2. Is it the one? The equation of that curve? Yes, when I take this one up here, right? Okay. Now, we need to differentiate because to get the gradient, to get the equation of the curve, you need the gradient. And we get gradient through differentiation here. So you need at least a coordinate through which a line passes and the gradient to find the equation of a straight line. So dy dx here is going to be equal to, when this one comes down here, it will multiply with that 4. Then we have the 2x here minus 1, then reduce the power by 1, then times the derivative of the denominator here. I mean, what is inside here, using chain rule. So that will be times 2. So meaning this one is giving us negative 8. Is it negative 8? 4 times 4, that would be negative 16. Then using rules of indices, I can take this one down, and it becomes 2x minus 1, then to the power of what? 3. So at b, okay, which is 3 over 2, 1, what is dy dx? So dy dx is going to be negative 16 out of 2 times 3 over 2, which will be a 3 minus 1. That will be 2. 2 cubed is 8. Then negative 16 over 8 will give us a negative 2. Okay, so from here, then we can find the equation of the tangent. Equation of the tangent at b. Okay, 3 over 2, then 1. Remember, it is y minus y1, which is equal to m into x minus x1. Now, this will be y minus, what is y1? y1 is a 1, then m is negative 2. Remember, the gradient at the point of intersection of the curve is the same as that one of the tangent. Then x minus 3 over 2. Okay, now on x-axis, because this one we need to know where it cuts the x-axis. On x-axis, y is equal to what? 0. So that means here we shall have negative 1. Then when we open the brackets, this will be negative 2x, then plus 3. So making this x the subject of the formula, we shall have 2x, which is equal to 3, then plus 1, not so? So x will be equal to 4 divided by 2, that will be a 2. Okay, so that means here we are having a 2. Okay, we keep that one there. And then, in fact, we are going to have that coordinate 2, 0. Then we do the same. We go and find the equation of the tangent. I mean, the equation of the normal. But we begin with the gradient of the normal. And since the normal and the tangent are perpendicular lines, that means gradient of the normal will be equal to negative 1 over gradient of the tangent, which is negative 2, because you know that the product of the gradients of the two lines that are perpendicular is always equal to negative 1. That is what you write as m1, m2 is equal to negative 1. So this one will give us a positive a half. Again, using, now we need to find the equation of the normal. Okay, equation of the normal. We have y then minus 1, which is equal to gradient of the normal is a half into x minus 3 over 2. Then we know that on y-axis, on x-axis, then y is equal to what? 0. So here we shall have negative 1, which is equal to a half into x minus 3 over 2, right? Then I can multiply all through by 2, so this will be negative 2, then x minus 3 over 2. When this one comes this side, we shall have negative 2, then plus 3 over 2. That one will give us the x. So 2 times negative 2, that is negative 4 plus 3, that will be negative 1. So meaning here x is going to be equal to negative a half. So that means I will have negative a half here, and then 0. Okay, so that means I can even put on this triangle. Here we have negative a half, and then we have 2 here. Okay, very important. So we needed this point, and we also needed this point here. Now I can sketch my triangle here like this. I have from here up to there where B is, then this one comes here. This is on the x-axis. So we have this one 90, B is 3/2 or 0 here. No, it is actually 1. Then this coordinate here is 2, 0. Then this coordinate, this point here is negative a half and 0. So we need to get this and this, those lengths, right? Okay, let's begin. We need this one here is going to be the square root of 3, or I can say 2 minus 3/2 squared. Okay, then 0 minus 1. So 0 minus 1 squared. So what do we get here? This one, 2 minus 1.5, that is a half. So half squared, that is a quarter. A quarter plus 1, that will be 5/4. Okay, so when we get root of 5/4, this one is the same as saying root of 5, then divide by root of 4. So that will be that one there, 2. So we shall have a root of 5/2. Then when we come to this one here, this one will be the square root of now 3/2 minus minus. So that one will add up. Then we square, then plus 1 minus 0 squared. So what do we get here? First of all, this one will be 4/2, that is a 2. So squared, what do we get? 4. Then 4 plus 1, 5. So this one will be root of 5. That means area of the triangle, which is formed here, is going to be equal to, remember it is a half, times the base times the height. So our base can either be this one or this one. Okay, so we can have root of 5 then times root of 5/2. Now root of 5 times root of 5, that one gives us a 5. And then 2 times 2, that one gives us a 4. That means our answer is 5/4 or 1.25.